Okay, let's do one more question. That small o of gn and small omega of gn. I have given all the definitions for small omega of gn, small o of gn, all that in my first video. So you can watch that first, then you can understand this question. Okay, so all these are set of functions. Okay, so it's telling that the set small o of gn and small omega of gn, the intersection between them is empty. Okay, so we have to prove that intersection of small o of gn and small omega of gn is empty. Okay, so to prove that, I'll use here the contradiction method. Okay, what we do in contradiction method, we assume something. Okay, then due to our assumption we find something. Okay, we find some conclusion which conclusion contradicts the fact. Okay, this conclusion contradicts the fact. Okay, so because we have assumed something that is giving us some conclusion that contradicts the fact, so what we get the conclusion later, that our assumption is wrong. Okay, so this is the process of using contradiction. Okay, so here I'm assuming let small o of gn intersection small omega of gn is not equals to phi. Okay, so if this is not equals to phi, then there will be some function that is belongs to this and belongs to this, means there will be some common function between them. Okay, let's say that common function be tn. Okay, so tn belongs to small o of gn. Okay, and tn belongs to small omega of gn also, because that is in their intersection. Okay, so as tn belongs to small o of gn, so I can write here, due to the definition of small o of gn, I can write here 0 less than equals to tn is strictly less than some constant c into gn for all n greater than equals to n0. Okay, and c greater than 0. Is that fine? So now, because tn belongs to small omega of gn, I can write here 0 less than equals to some constant into gn strictly less than tn for all n greater than equals to, let's say I'm taking here n1 and taking here n0. Okay, and c greater than 0. Okay, so now take m as a max of these 2 points n0 and n1. Okay, so now combining these two equations, let's say this is equation I and this is equation 2I. Okay, so now combining these equations, I can write here for all n greater than equals to m and c greater than 0, 0 less than equals to c into gn less than, this is strictly less than, okay, less than tn less than c into gn. See, I'm taking 0 less than equals to c into gn, strictly less than tn, that is strictly less than c into gn. Okay, and because I have taken m as maximum of n0 and n1 and c greater than 0. Okay, so now I'm dividing c into gn here with everyone. Okay, this will give us 0, so no need to write there. Okay, fine. So what this will give us? This will give us 1, this will give us 1. Okay, so we get this equation now. Okay, this is 1 and this is 1. Okay, so 0 less than equals to, forget about this part. Okay, so now 1 strictly less than some quantity and that is strictly less than 1, that implies 1 less than 1, where we know that 1 equals to 1. That's the fact. Here the contradiction arises. Okay, so due to the contradiction, what we can conclude here, that our assumption that we have taken a small o of gn intersection small omega of gn is not equals to phi was wrong. Okay, hence small o of gn small o of gn intersection small omega of gn equals to phi.